Let's talk about limits and continuity in Calculus 1. So I have a limit of my function as my x approaches 3. We're going to solve this one first. Now, whenever you have a graph, just know that the horizontal axis are your inputs. The vertical axis are your outputs. So in this case, my x is approaching 3. So I can start over here to the left of 3. 3 is right here of my input. And as I slowly start to approach 3, I'll stop right here where my input is 3. And my output looks like it's at about 2. So in this case, I have 2. Now, what about my limit as x approaches -4? So I'll start all the way over here to the left of -4. And if I slowly approach my curve, here's my input of -4. My output is at about +3. So this is going to be a +3 right there. Now, what about just plugging in a number for my function? What is defined as my x is equal to 3 in my function? So my input here is going to be 3. And if I travel up here to my curve and I go to my output, it looks like we're at about 2. So in this case, I can plug in a 2 right there. Now, what about if I plug in my -4? So if I plug in my -4, which is right back here, what I'm going to do is I'm going to go right here, but I can't go up to this curve because notice that there's a hole right there, which means my function does not exist. So I have to travel past it and go to where we see this existing dot here. This right here exists at 6. Now notice that f of -4 does not match the limit as x approaches -4. So what that means is here we have discontinuity. This is discontinuous. Now what about on this left side? Do I have a continuous function here? And we're close, right? Because we have that x approaches 3 is equal to 2. We have that f of 3 is equal to 2. And we also have that f of 3 exists. So 2 of our rules are met. But the third rule is that we have to approach it from the left and the right side. Or I should say that's actually the second rule. So this we proved. We just need to prove this last rule right here. Well, if I start on the left side of my limit, somewhere on the left side, and I approach this point here, and I start on the right side, and I approach this point here, notice we're still going to end up at that same output of 2. So we have 2, 2, 2, so this function is going to be continuous.